In limiting reactants, what you are given is not just the mass of one substance, okay, like given 20 grams of, let's say acetylene, and then trying to figure out how many grams of oxygen are going to react with it. But in this case, I'm given both the mass of the acetylene and the mass of some oxygen here, okay? And they're just kind of randomly chosen. These 20 and the 40 are just randomly selected. So that means that one of these two will be completely consumed and I'll have excess of the other one. So our objective here is to figure out which one will run out. And the reactant that runs out, so to speak, or is completely consumed, is what is known as the limiting reactant. So let's start with our calculation here and figure that out. So let's start with, we'll just pick one of the two, and I'm going to pick the acetylene. So I'm going to start with 20 grams of acetylene here. And what I'm going to do is figure out how many grams of oxygen would be needed to react with that 20 grams, okay? So for now, let's just forget about the 40, and we're just going to figure out how many grams of oxygen would be needed to react with 20 grams of acetylene. So I'm on my way here. We took our molar mass of 26.04, and now we're converted it to moles of acetylene. And of course, now we do our mole-to-mole calculation, which involves 2 moles of acetylene, C2H2, and 5 moles of oxygen. And we know for every 1 mole of O2 that it will have a mass of 32.00 grams. Again, it's a diatomic, so we have to double that mass. So we have that, and then we just simply punch it in our calculators to see what, and I get 61.4439 grams of oxygen. And again, we're going to go back to our significant figures. We can see here we have 3 significant figures, and here we have 4. Here we have an infinite because of the exact relationship, and here we have 4 based on the masses that we were using. So we can only keep 3 significant figures here. So we have 61.4 grams of O2 will be our number of grams of oxygen that would be needed. So in this case, we have we're given 40.0 grams of oxygen, but we need here 61.4 grams of oxygen to react with this 20 grams of C2H2. So obviously we don't have enough. We don't have enough oxygen. So therefore, the oxygen is our limiting reactant. Okay, so again, we're given the 20 grams of acetylene. We're also given 40 grams of oxygen. If we start with our 20 grams of acetylene and calculate how many grams of oxygen we'd need, we find out that it comes out to be 61.4 grams of oxygen is what we needed. However, we only had 40. That's all we were given, so we don't have enough. So oxygens are limiting. Now, it could have been that you selected the oxygen instead of the acetylene to do the calculation, which is just fine. We could pick either of the 2 reactants to do our calculation here. So let's start with that one. So let's start with now, instead of the acetylene, let's start with our 40 grams of oxygen. So here I have 40.0 grams of oxygen, and we're going to do the same exact calculations except in reverse. And so I convert my grams of oxygen to moles of oxygen. And then we convert our moles to moles. So we're trying to find out how many grams of acetylene, again, are needed. So we know for every 5 moles of O2, we're going to have 2 moles of acetylene. And I know that for every 1 mole of acetylene, that 26.04 grams of acetylene will be needed. So do our calculation here and punch that in our calculators, see what we get. And I get 13.02 grams of C2H2. Now, I can only keep 3 significant figures because of the 40 here. There's only 3 significant figures there. So we have 13.0 grams of C2H2. So going back to our original problem, we were given 20.0 grams of C2H2. And this time we require 13.0 grams of C2H2. So what we needed was 13.0 grams to react with our oxygen. So we can see in this particular case that when we do the calculation in this way, we see that we're going to have an excess of 7.0 grams of C2H2. Therefore, the conclusion is still going to be the same. Our oxygen is limiting. So just to recap, if you're given 20 grams of one substance and let's say 40 grams of another, in other words, I'm given the masses of both reactants here, and one of these two is going to be the limiting reactant. In other words, one of these two is going to be in excess and the other one is going to be consumed. So we need to figure that out. So we pick one of the two. Doesn't matter which one we pick. Here I'm picking the 20 grams of C2H2 first. And we discover that we would need 61.4 grams of oxygen. Well, we don't have that many. We only have 40 grams. So as a consequence, we can see then that our oxygen is our limiting reactant. Okay. It could have been that you chose the 40 grams of the oxygen to start with instead of the 20 grams of the acetylene. So if we did it that way, again, just to recap, we started with our 40 grams of oxygen, and we go through our calculations and we find out that we needed 13 grams of acetylene. So we determined then that we have an excess of 7 grams of acetylene. Well, if we have excess of the acetylene, then the other reactant is obviously completely consumed. So then the oxygen is then determined as the limiting. So in both ways, it doesn't matter which one you choose, you both get the same result that the oxygen is limiting. However, by choosing the oxygen, I also can calculate the excess amount or the amount that's going to remain of the acetylene. Now, a problem might go further and also ask how many grams, let's say, it might ask you how many grams of water vapor will be produced. Okay, so now the question is, do we use, okay, so we're trying to figure out how many grams of water vapor will be produced. So the question is, do we use the 20 grams of the acetylene or the 40 grams of the oxygen to determine the mass of water that's going to be produced here? So we're trying to determine the grams of water being produced here. Well, we cannot use the 20 grams of acetylene because not all of it's going to be used. In fact, only 13 grams of this acetylene will be used. So we could either use the 13 grams of acetylene, or we can use the 40 grams of the oxygen. We can choose either one. So in this case, I'll just use the 40 grams of oxygen to determine the mass of the products. So what I'm ultimately saying here is that you always use the limiting reactant. Okay, this one's my limiting. So we always use the limiting reactant to determine the masses of the products. Okay, and we also use the limiting reactant to determine the excess mass of the non-limiting reactant. Okay, so let's figure out this mass of our water produced. So again, we're going to start with our limiting reactant, 40.0 grams of oxygen, and 32.00 grams of oxygen we know is 1 mole of oxygen And then we know that for every 5 moles of oxygen, we'll produce 2 moles of water vapor. And for every 1 mole of water vapor, it will have a mass of 18.02 grams. And we can do our calculation to figure out how many grams of water vapor would. And I get 9.01 grams of water vapor. And so that's how many grams of water vapor will be produced in this reaction. And that is the main reactants.